Hello, guys. Welcome to Ramta Solutions. Welcome to your grade 12 functions and inverses. Today, we are looking at the exponential graphs and their inverses, which we call logarithms. Okay, so without any waste of time, let's remind you what your exponential graphs look like. So they come in the form f of x equals a times b to the powers x plus p and plus q. Now we're going to explain what some of these parameters mean. So a, what a does, it basically tells where the graph lies. Okay, it tells where the graph lies. Okay, it tells where the graph lies. For example, when this A is positive, your graph will lie above asymptote. Okay, when A is positive, it will lie above asymptote. Okay, it will lie above the asymptote. And when this A is negative, the graph will lie below the asymptote. Okay, it will lie below the asymptote. Okay, it will lie below the asymptote. Okay, when a is negative, the graph will lie below the asymptote. Now this b, what it does, let me not explain it as yet, but I will show you what it actually does. Okay, I will show you what it actually does. And this p, what it does, as is the case for all the graphs, it represents a horizontal shift, remember, or horizontal translation. Okay, remember, horizontal shift is to do with moving to the left or right of the function. If this p is positive, the graph moves to the left, and if this p is negative, the graph moves to the right. It's no mistake, guys. Okay, it is no mistake. All right. Okay. Now, this Q represents vertical shift 1. It represents vertical shift. Okay, it represents vertical shift. Okay, remember, with vertical shift, we are concerned with movement up and down of your curve. So if your Q is positive, your graph shifts up. If your Q is negative, your graph shifts down. Secondly, this Q represents the horizontal asymptote. Okay, it represents the horizontal asymptote, the only asymptote of this graph. Okay, it represents the horizontal asymptote. Okay, so horizontal asymptote, as you can see, it's these broken lines that pass through the y-axis. And what is it? It is y equals q. Okay, the horizontal asymptote of your exponential graph is y equals q. Okay, so what I'm going to give you now is the summary of how your exponential function looks like. But I also need to expand rather on this equation. So let's go to the next page. So we are saying f of x, of course, which is equal to y, is a times b to the powers x plus p, of course, plus q. The condition of this equation, I want to basically, the restriction of this equation is that your b is not equal to 0, and not only that, b is not equal to 1. Okay, b is not equal to 0 and b is not equal to 1. Okay, and to be honest with you, this b is supposed to be greater, and let me not say greater than 1. Okay, it's supposed to be like this. Okay, But to be honest, it's supposed to be greater than 0, not 1. It's supposed to be greater than 0. It shouldn't be less than 0. Okay? It shouldn't be less than 0, but let me leave it here. Okay? It shouldn't be 0. It cannot be less than 0. And it should not be equal to 1. Okay? So these are the conditions that we need for this equation. Okay? These are the conditions that we need for this equation. So as you can see, I should have said b is greater than 0. Okay, I should have said b is greater than 0. Right? Will that be correct? Yes, b is greater than 0. It's not supposed to be less than 0. Right? It's not supposed to be less than 0. B should not be negative. Okay, b should not be negative. So let's fix it. It is greater than 0. Okay, it is greater than 0, and then it should also not be equal to 1. Okay, it should also not be equal to 1. Okay, all right. So these are the conditions. All right. So now, the summary of the expected graph. I'm just gonna say it like this: summary of the graphs. Remember, I'm not really drawing them much. It's something that you must know. When a is positive, and then when a is negative. Let's try when b is greater than 1, and then we're going to try when b is greater than 0 but less than 1. Okay, when b is greater than 0 but less than 1. Okay, all right. All right. So when b is greater than 1 and your a is positive, remember your okay, you don't remember, but if you remember, cool. Your curve will be increasing. It will be moving like this. Let me change the color. Perhaps let me take red wood too. It'll be like this. Okay. I'm gonna increase the font size as well. It'll be like this. Okay. Now, when remember we said when a is positive, the graph lies above the asymptote, and then when it's negative, it lies below the asymptote. It'll be like this. Now, when b is greater than 0 but less than 1, your graph will be like this, especially when a is greater than 0. Now, when a is less than 0 but b is greater than 0 but less than 1, it will be like this. As you can see, it will be increasing. Do you guys see this? So these are the graphs that we get when we draw our exponential graphs. Okay, these are the graphs that we get. Okay, great. Now, and let's see. Now we are then going to give you, let's try an example. Okay, we are going to have an example. So, example, let's just plot an exponential graph. So, sketch the graph of, oh, come on, buddy. Sketch the graph of f of x equals 2 to the x, right? So, as you can see here, maybe let's begin with the x-intercept. So x-intercept solution, let me just say solution. It's important that we get this. So, so our solution, we will say, first thing first, x-intercept. All right, x-intercept. So for the x-intercept, we will say f of x equals 0. What is f of x? It is 2 to the x equals 0. This says no solution. All right, no solution. Therefore, no x-intercept. Right? Therefore, it has no x-intercept. Okay, let's talk the y-intercept. Let's talk the y-intercept. So with the y-intercept, we will say where there's x, we put 0. What is this? 2 to the 0. This is 1. Therefore, it will be 0 and 1. Okay, now let's look at the asymptote. Let's look at the asymptote. Asymptote is where we say y is equal to q. Let's go back. What is the value of q here? Look at this. What is the value of q? It is 0. Can you see that? So our asymptote is y equals 0. Okay, y equals 0. Okay, and ooh, I think I need to add some further information. Let me see. Let me add some further information here. I want to talk domain and range. So let's begin with the domain. The domain of an exponential graph is that it'll take all x values. So we'll say x is an element of real numbers. And then its range will depend on the value of a. For if a is positive, the range we will say y is greater than the q, the value of q, right? The vertical shift, sorry, not the horizontal, the vertical shift. Okay. And then when a is negative, the y value will be less than the value of q. Okay. Maybe let me show you in the summary of the graphs. You see this? Uh, So here, for example, you have your asymptote. The values of y are greater than the asymptote, even here. And here, when a is negative, they are below the asymptote. All right? They are below the asymptotes. All right? So these are all that I needed. Now I'm happy I can proceed. Okay. Now coming here, we said asymptote y is equal to 0. Now the range, domain, obviously, when they ask you what is the domain would always be x is an element of real numbers. In the range, this one, a is positive, and the value of q is 0. Therefore, we will say you don't need this. Okay, you don't need this information. This is for you only. You don't need to write it. You will therefore say y is greater than what? Y is greater than the asymptote, which is 0. Okay, that's it. Now, let's sketch these graphs. I'm gonna use a grid. Let me increase its size a bit. Okay, I think it's good. Come on, buddy. Yeah. Right. So here we are. So let me see. 3, 2, 1, 0. 1, 2, 3. Moja mbili tatu. Nne mbili taro. And so on. Okay. So our x-intercept, we didn't have it. Our y-intercept, we had 0 and 1. Here was it. Let me think of another point. Another point that we can think of. Let's think x equals 1. So let's look for f of 1. F of 1 would be, what is x? You put 1. This is 2. So the point is 1 and 2. So where is it? When x is 1, y is 2, it's this one here. Then, yeah. Do not forget the negatives here. And of course, this is y. This is x. Right? So our curve looks something like this. Okay, so this is f. Okay, this point here is 1 and 2, and this one here is 0 and 1. So we're good. Remember, your asymptote says you should not cut y equals 0. As you can see, your graph will never touch the x-axis. Okay, so let me do this. I'm removing the grid, but this is it. So this is our graph. Okay, now we good. Now let's head to, I want us to determine the inverse. So the second part is determining the inverse. Determining the inverse. Okay, determining the inverse. So with this is a reflection on the line y equals x. Okay, this is a reflection on the line y equals x. This means what was x becomes y, what was y becomes x. Okay, so I need an example for this. By the way, you see, if we want to draw the inverse of this graph, it's easy. What was x will become y, what was y will become x, and just like that, we will be done. And I can show you now. Let me show you. You see, this is 0 and 1. Now, for the inverse, it will be 1 and 0. Remember, what was x becomes y, what was y becomes x. This is 1 and 2. What does it mean? It will be 2 and 1, right? And your graph will be moving like this. And what is this? This is your inverse. Do you see this? Look at this now. This is 2 and 1, and this is 1 and 0. Do you see this? But we're going to prove this. So we're going to have an example on this just now. So we said when we are determining the inverse is basically a reflection on the line y equals x. Okay? It's basically a reflection on the line y equals x. Okay? So the inverse of an exponential graph is a logarithm. Okay? The inverse of an exponential graph is a logarithmic graph. Is a logarithmic graph. Okay. Okay. So we're gonna try an example just so you can see and to verify this. Example, determine the equation of the inverse of f of x equals 2 to the x, and draw the sketch of this inverse, and draw the graph of this inverse. What is this? To sketch is to draw, and draw the graph of this inverse, right? Of this inverse, f to the minus 1 of x. Okay. All right. So our solution, let's begin. Our solution, we will say, and what we know that first, we say f of x, we know that it is same as y, it is equal to 2 to the x. I like writing this instruction, reflecting on, this is me guys, you don't have to, but I like it. Reflecting on y equals x. So what is this? What is x you put y, what is y you put x. So we say this then becomes x equals 2 to the y. Do you remember? Whether it's x you put y, whether it's y you put x. All right, perfect. Now let's go. Now to do this, I will drop the link to a lesson on logarithms. It'll pop at the top right of your screen. It'll pop, and when it pops, you will get a link to the video that explains how to simplify or solve logarithmic equations. Okay, it'll pop. You can check it out just now. All right, for sure. As I'm speaking, it's popping. All right, all right. Now, of course, guys, only if you're watching this on YouTube, eh? But if you have downloaded the video, it's not gonna pop. All right, so now we need to solve for y, but we log both sides. As we log both sides, it'll be log x equals log 2 to the y, which when you further simplify, it'll be log x equals y log 2. Now divide throughout by log 2, you will be having log x over log 2 is equal to y. Otherwise, we don't like it in this way. We prefer it to be like this: log x base 2 is equal to y. So this is the equation of your logarithm. So guys, these steps are not necessary. From here, you can get here, but I prefer to show them. Okay. And you don't have to show the step, because from here, you can directly come here. but I was just showing you how you get to this. However, you will watch the video that was popping a few seconds ago and it'll guide you on this. Okay, so this is the equation of the inverse. Therefore, what do we say? We say f inverse of x is log x base 2, right? It is log x base 2. As you can see, this is the this is the inverse of y is equal to 2 to the power x. So that means if you have y is equal to 2 to the power x, you just swap the values around. What as x becomes y, what as y becomes x, and you are good to go. All right? And you are good to go. Okay? You are good to go. Hence, this is the graph of the inverse. Okay? So you can also test these values on your calculator. Remember, let me just put it here. We found f inverse of x to be log x base 2. Let's test it out. F inverse of 2. Let's see. On your calculator, what is this? Your calculator will return 1, isn't it? Remember, the calculator doesn't have, what is this? f to the minus 1, but I think current calculators have. All right. So when you say log 2, ooh, what did you do, buddy? Okay. When you say log 2 base 2, you get 1. Please confirm. Yes. Now let's try another value here. X equals 1. Let's see. Log 1 base 2. Your calculator returns 0. Isn't it? Yeah. And this is you plotting. You can also think of any other y value you can think of. Being it f inverse of, let me say, negative 2. You see, whatever you can think of, it'll give you a certain value, but I think you get the gist of it. Right? You get the gist of it. Right? Perfect. So we can proceed. So these are the things that you need, right? These are the things that you need. So I want to copy this guy. I want to copy this guy because I want to use him just now. Okay. Copy to current page, but I really do not want him in the current page because I want him in the new page. So you saw now the 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 graph of this guy, right? So now let's summarize this. Okay, now let's summarize this. So let's summarize this. Go back to black. So summary, okay, or observation. Okay, observation. Let me not call it summary. Relation between. Think that's better. Relationship. I get a mojolo, guys. Relationship between. A relationship between exponential. Okay, a relationship between exponential, and logarithm. Okay, and logarithm. Ooh, what is happening? And logarithm, right? And logarithm. Okay, so I'm gonna paste that graph that we had there. Let me paste it. Use it. Now I want us to compare the two. Okay, I want us to compare the two. So we're gonna have, let's begin with the x-intercept, and then we're gonna go to the y-intercept. We're gonna go to the domain. Before the domain, let's go to the asymptote. Let's go to the asymptote. Okay, let's go to the asymptote. Let's go to the domain. And lastly, the range. Okay, and lastly, the range, we're gonna look at the original and the inverse. What is the x-intercept of the original? We do not have it. What is the x-intercept of the inverse? 1 and 0. What is the y-intercept of the original? 0 and 1. What is the y-intercept? Sorry, it was 0 and 1. The y-intercept of the inverse? We do not have it. What is the asymptote of the original? Y equals 0. Do you guys see this? Y equals 0. And what is the asymptote of the original? As you can see, it is approaching the y-axis but not touching it. This is where x is equal to 0. So x equals 0, right? What is the domain of the original? It allows all x values. What is the domain of the inverse? As you can see, it allows all x values but those that are above x equals 0. So here x is greater than 0. Alright? Because we said it allows all x values, however, it must be all x values that are greater than 0. To the right of x is equal to 0. Can you see that? Good. What is the range of the original? It says y, it allows all y values above x equals 0. So that means it must be not above x equals 0, above y equals 0. All right, above this line, y is equal to 0. But it allows all y values except those that are equal to 0 and below. So y is greater than 0. What about the range of the inverse? It allows all y values. So y is an element of real numbers. Right? Y is an element of real numbers. Right? Now, as we look at this, let's look at this. What does the x-intercept becomes for the original? Becomes the y-intercept of the inches. What was the y-intercept for the original? Becomes the x-intercept. Remember, you need to swap the values. What was x becomes y, what was y becomes x. What was the asymptote? It was y equals q 0. Then it will be x equals whatever value it is. Okay? Domain. X is an element of real numbers. Right? Domain, x is an element of real numbers. Because you're saying you're reflecting on the line y is equal to x. Or as x becomes y. You only change the value of x to y. It will become a range in the inverse. Right? Range, y is greater than 0. Because you have to change the y value or the y to x, it will now become x is greater than 0. Do you see this? This is what you need to do. So generally, remember to swap the values. So generally, x-intercept with the values swapped will become y-intercept. Y-intercept will become x-intercept. Swap the values around. Domain will become range. Only change for the domain, you said x is blah blah. When you want to find the range of the inverse, you will just say y is blah blah. That was given in the domain. Now you have the range, which is y is blah blah. For the domain, you just change that y. You say now it'll be x is equal to, or x is an element of blah blah. So what I'm saying, whereas the domain becomes the range, whereas the range becomes the domain. You just swap what was x to become y. Okay, and that's it. So let's see. So yeah, this is what we had, and this is all you need for your exponential graphs and their inverses. Their inverses are logarithmic graphs. Okay, I will see you when we do past papers on this section. So with that being said, this is the last video that explains exponents, rather graphs and their inverses for your grade 12 syllabus. So the next time I see you, it's past papers. Remember, guys, if you want to get in touch with us, visit our website www.ramtasolutions.co.za. And of course, you can follow us on all these social media platforms. The link to these platforms are provided in the description of this video. And by the way, we must also introduce our WhatsApp channel. You can also follow us there. So, with that being said, ours ends here. We'll see you next time. And the next video that we will be uploading is on trigonometry, because after functions, you're going to trigonometry. So, yes, or currently you must be doing trigonometry. So, yes, we will see you with trigonometry. So, this is it, guys. And bye bye.